Good evening. As you watch this from the safety of your homes, your offices, well, bear in mind that Guam, a US territory in the area of Micronesia, is in the thick of it. It is being confronted with a monster typhoon. A category 4 hurricane is currently hitting Guam as we speak, and the situation is ongoing. However, we will try and bring to you the latest updates as well as the understanding of what a cyclone or a typhoon is and how exactly it works. Namaskar, good evening once again. I am Bhuvan Apurva Jha for Study IQ IAS. As today, we will take a look at Guam, and cyclone hurricane typhoon Mawar is currently hitting the island of Guam in Western Pacific, and Guam is indeed in the thick of it. Straight away, jumping into what we know so far, well, the typhoon has strengthened rapidly in the preceding days, and currently it was supposed to pose a triple threat to this tiny island. What is the triple threat that it is confronted with? Well, number one is the category 4 hurricane. At the same time, the storm surge that this hurricane brings with itself, and thereafter the torrential rainfall, extensive rainfall being predicted, close to 20 inches in just a short span of few hours, Guam is currently facing as this presentation comes to you live on Study IQ IAS. And to make matters worse, well, this is a slow-moving typhoon. It's moving extremely slow to the point that it is 6 miles per hour is the recorded speed. Now, you might ask me, what's the importance here? What's the problem if it's moving slow? Well, it's a big problem. Why? Firstly, because it leads to a prolonged impact. The impact of the hurricane will be long-lasting. Rather than, say, a shorter duration of time, here is a hurricane, here is a typhoon that will be passing through this tiny island over a longer period of time. With it, again, you have higher wind damage that's going to be happening a lot. At the same time, storm surges, increased chances of storm surges, close to 25 feet has been already said. Rainfall, extensive rainfall being predicted for this tiny island, and indeed, our prayers go out to Guam as we speak currently on Study IQ IAS. Obviously, a humanitarian crisis may be building in Guam, but again, emergency has been sounded. The US administration has swung into action. Its relief and rehabilitation efforts are already underway, but currently the eye of the typhoon has just passed Guam, and we are still to understand the full extent of the damage of this particular category 4 typhoon that has hit the small island of Guam in Western Pacific. Going forward, we will try and understand what exactly are the predictions here. Now, it is being said that the storm surge of up to 25 feet will be expected when this typhoon crosses, which is going to lead to extensive loss of life and property on the land. Well, obviously, lives have been evacuated, people are safe, a large majority of them, but property will be badly hit. At the same time, we are looking at coastal flooding because of this whole category 4 hurricane. You are looking at close to 10 to 15 inches of extensive rainfall that might go up to 20 inches of rainfall. Bear in mind, all of this happens in a very short amount of time. It's not a long period wherein you are getting 20 inches of rainfall, which means you are going to have flash floods, there will be problems with health, there will be problems with relief, all of that coming in together as cyclone, typhoon, hurricane Mawar, the way you want to understand it, a category 4 typhoon currently hitting Guam in the Western Pacific. Now, before we go forward, at this moment, it will be important for all of us to consider as to how exactly a typhoon or a cyclone is formed. Well, obviously you have tropical cyclones and temperate cyclones. For the purpose of understanding today, we will delve into tropical cyclones. Now, what is the condition that you require for a tropical cyclone to form itself? Well, you need a warm water, a large mass of warm water, which is essentially high sea temperatures of at least 27 degrees centigrade, which means there's going to be a lot of warm water around Guam, again in the middle of Western Pacific. It does have access to a lot of warm water there. It is in the middle of nowhere, really. If you look at it, Micronesia, a tiny part in the middle of the Western Pacific. And so it does have access to a lot of warm water. Now, what happens due to the warm water? Well, you are going to have massive amounts of evaporation. Once this evaporation begins, you are going to have the air that has gone up, it's going to cool down eventually. So a low pressure area is created downwards, whereas upwards, the high pressure, the wind is going to straight away run inside, trying to fill in that gap that has been created there. So when this starts, now you need to understand that there are certain conditions that need to be fulfilled for a tropical cyclone to form. One of them, like I told you, was that you need high sea temperatures of at least 27 degrees centigrade. At the same time, you need converging winds. You need a lot of winds to come together, and that will eventually form a typhoon or a hurricane. Now, that wouldn't happen near the equator. Why? Because, well, equator is the area of calm. All the convergence happens upwards near the ITCZ. That's the Intertropical Convergence Zone. So when in this area, you have warm water, then you have converging winds, and then you have low wind shear. Now, what exactly is low wind shear, you might ask? So when you have this particular formation being built, you do not need something to come and slice it from the middle. You do not need strong horizontal winds hitting it, which will eventually dissipate it or completely annihilate it. So you need areas where you have low wind shear. At the same time, you need to be at a sufficient distance from the equator. Like I told you, ITCZ, sufficient distance from the equator. Why? Again, because Coriolis force, the force that will drive this whole assertion for me, is going to be present there. It's not going to be present at the equator. So once these have been done, and along with that you need baroclinic instability. Once these conditions are fulfilled, now you have the ingredients prepared for a brilliant cyclone or a typhoon or a hurricane, the way you want to understand it. A monstrous one could be created. You have the ingredients in place. So like I told you, once this high pressure to low pressure transition starts, eventually a column of low pressure will develop around the center. You will have a column developing herein. This will make sure that the winds are forming around that helix. You'll have all the circulation happening around the helix, whereas once the helix starts to move away, the eye of the storm is formed, a place of calm. You wouldn't be able to tell that you're in the middle of an eye of a storm. For you, it'll be a complete area of calm there. However, just outside the perimeter of the eye, complete chaos, complete destruction follows. At the same time, as pressure in the central eye weakens, the speed of the wind around it increases. The weaker this becomes, the faster and the stronger this becomes. All of this put together lead to a massive cyclone or a hurricane or a typhoon. The names might be different, but the connotation is the same. Once this has been taken care of, then comes the categorization of the cyclone. Like I told you, Typhoon Mawar is a category 4 typhoon, which means it falls in the extreme damage category. Like I told you, again, that this is expected to cause a lot of property damage, at least in the minimum in Guam. And it's because you are going to expect speeds of close to 250 kilometers per hour, wind speeds close to 250 kilometers per hour. Along with that, the storm surges. Along with that, the extensive rainfall. Along with that, you have landslide. All of these put together contribute in making a humanitarian crisis, one that we ardently and fervently pray that doesn't happen in Guam. Going forward now, let's understand exactly what's happening with Typhoon Mawar. Just a couple of days ago, it wasn't in the news, but suddenly it picked up speed, it picked up pace, it picked up the energy supply that it needed. So what exactly happened there? Extreme rapid intensification. Now this was observed with Typhoon Mawar. So what exactly is extreme rapid intensification? In fact, this particular typhoon gained close to 55 kilometers per hour in just less than 24 hours. It was traveling at some lesser speed, and suddenly, in just 24 hours, you have Typhoon Mawar picking up speed. Imagine the response of the disaster management authorities, who would probably be caught unaware. But again, Guam being an island state would well know through historical experience to be prepared at all times. However, this does lead to response time being absolutely minimal. Especially now that you have climate change, sea level temperature is rising, which means that the NDRF, at least in the Indian context, disaster management forces will need to be taking this into account insofar as their strategy going forward is concerned. Now, coming back to Typhoon Mawar. So, what are the ingredients exactly which caused it to gain such speed in such short amount of time? What exactly happened? Well, number one, upper level winds around the hurricane need to be weak. This happened with Typhoon Mawar. Like I told you, you do not want horizontal winds hitting the formation of the typhoon or the hurricane. This was absent here. The upper level winds were weak. At the same time, you need warm ocean water. Why? Because warm ocean water is essentially the fuel on which a typhoon or a hurricane functions. It's the energy source for this particular monstrosity. Given that Guam is in the middle of Western Pacific Ocean, this was there in large abundance. All of this put together contributed in this rapid escalation of the magnitude and the force of Typhoon Mawar that's currently hitting Guam in Western Pacific Ocean. Now when we go forward, we try and quickly understand two concepts that are not necessarily associated with Typhoon Mawar, but you should be aware of. Number one is the Fujiwara effect. Now, if you were to look here, you have two particular typhoons who are in fact merging into one to become one. This binary interaction between two typhoons to either form a bigger typhoon or merge into each other and dissipate is known as the Fujiwara effect. It was named after the Japanese scientist who in fact chanced upon this in his observations and his research. The next one is the brown ocean effect. Now, like I told you, just the fact that you have this large ocean water body, this is giving fuel to the cyclone, to the typhoon, to the hurricane. And so common sense would dictate that when suddenly you were to make landfall, when you were to go and hit a landmass, well, the fuel source would be cut off because there would be no moisture anymore. And so eventually it would dissipate. That would be expected, that it would probably weaken into a depression. However, in some cases, that does not happen. In some cases, the typhoon or the hurricane, after hitting the landmass, continues deep into the landmass. So where does it get its fuel from? What exactly goes wrong there? Well, in certain cases, the typhoon is able to source its fuel from the moisture in the landmass, on the landmass. So, when the brown ocean effect is in play, tropical cyclones maintain strength or even intensify over land surfaces. Again, it's the exception to the rule. The rule being that, well, if a tropical cyclone hits a landmass, it's eventually going to dissipate and dissipate fast. However, when brown ocean effect is in play, that wouldn't happen. Now, where would you find this? Where would you chance upon something like the brown ocean effect? Well, one place is United States and China. However, Australia does seem to have the most conducive atmosphere to make sure that this happens, this happens on a regular basis. In fact, they have a name for it called Aguka bombs. So you had Cyclone Tokte, you had Hurricane Ida. These are the examples of brown ocean effect in the recent past, where these particular monstrosities have managed to go deep into the landmass and cause extensive damage in spite of having no fuel source to fuel that particular movement. Now, when we move forward, I promise in every video that I bring you an India perspective to whatever I do, and well, here is the India perspective. So here you have Guam in the middle of the Western Pacific Ocean. Now, such strong storms impact the wind pattern over hundreds and thousands of kilometers. In fact, these tropical cyclones can have ranges from 100 kilometers to 2000 kilometers. They can span across multiple latitudes, up to 8-degree latitudes could be their expanse. Obviously, they are going to be affecting the weather pattern there. Obviously, they are going to have long-term ramifications insofar as the weather pattern of that region is concerned. This happens with these hurricanes and these monster hurricanes and these monster cyclones too. So the strong pull of winds of these storms invariably depletes moisture over India. you have all of these moisture now headed towards Guam. So with this moisture now going there to fill that gap, what exactly is going to happen? Well, monsoon in India is going to be affected. Why? Because we are dependent on low-level moisture transport from the Indian Ocean. Because of the sapping of this moisture, this is going to weaken the monsoon stream for us. So this particular cyclone is going to have effect for us too. Our monsoon could well be compromised, could well be hit at least in a partial manner. Why? Because all of the moisture from the Indian subcontinent, the Tibetan subcontinent, it's all headed there. The timing again is conspicuous. Why? Because it's coinciding with the normal dates of the southwest monsoon's arrival over the Indian subcontinent. With this happening exactly at the same time, coupled with the fact that some people have said, well, we have in fact conclusive evidence that El Nino might in fact be happening this year. Well, this does not bode well for the Indian agriculture, the Indian monsoon. So super typhoons are known to delay or weaken the onset conditions over the Indian subcontinent. The onset conditions of the monsoon might be affected because of Hurricane Mawar that is currently hitting Guam in the Western Pacific Ocean. Indeed, it's our prayers go out with the people of Guam at this hour. But again, it's important to understand the relevance, the information around this whole issue. Again, it's a developing information. We do not have confirmed information of what exactly is happening there. We have some videos and texts, but we will avoid getting into all of that for the time being. However, before I do let you go of this short presentation, my dear viewers, may I request you that I do, in fact, dabble into a lot of current affairs and my Indian perspective, presenting an Indian perspective on whatever that we discuss here. Please do make sure to check out the other videos on this channel, Study IQ English IAS. Till I see you tomorrow again with another topic of international or national relevance, where we will discuss, in fact, again, the India perspective to it too. This is Bhuvan signing off for Study